One reason why Wi-Fi penetration testing is important is that wireless security is hard. It's hard. An organization that wants to secure its wireless network needs to be aware of many factors and considerations, many challenges, and compared with a wired network, wireless adds additional challenges. What I mean to say is that both wired and wireless networks have certain security-related challenges in common. And if you're trying to secure a wireless network, you have additional challenges to deal with. Here's a high-level list of the challenges that an organization would have to deal with in order to try to secure its wireless network. Firstly, there are the general considerations, which are things that apply to both wired and wireless networks. The next slide is going to go through some of these general considerations. So we move on to the next item in this list. When you have a wireless network, you also have the specific challenges arising from wireless, such as the broadcast nature of the wireless medium. Unlike a wired network, where the signal is somewhat constrained within a wire, the wireless medium is inherently broadcast. Yes, you can have directional antennas instead of omnidirectional antennas, and that can channel your energy in a certain direction, but it's not really the same as sending it in a wire. And if you really want to do really pinpoint accuracy with directional antennas, that runs into other challenges with your antennas as well. Furthermore, if devices are going to be moving around, you can't really be doing that very well, because you have to keep tracking and shifting your beams, and it's not really the way to go. So it's something that we have to deal with from the security point of view. Additionally, there are specific challenges arising from mobility. As you move around and you're changing your point of attachment to the network, that makes it more difficult to secure your communications compared with wired communications, where you're physically connected to a network and you're not really moving from that point of attachment. Then wireless devices also need to be concerned about battery consumption of energy, and that also makes it difficult. So anyway, let's take a look at the general considerations first. In any network that's trying to secure the communications, there are cryptographic algorithms being used. These use sometimes pretty sophisticated math to secure the communications. However, it's not easy to get these right, so there can be flaws in the building blocks, whether it's the pseudo-random number generators, ciphers, whatever building blocks they're using. Sometimes there are flaws that can be discovered in them, and then that can compromise the security of your system. Even if building blocks are themselves okay, sometimes then the combination of these building blocks, if you don't combine them appropriately, that can also lead to compromises in your security. Now, even if you get all that right and you have a theoretically sound system, you might still be having poor usage of certain aspects of your system. So for example, you might have everything great, but the keys that you're using are just too short. Then you might become vulnerable to simple brute force attacks, because there's not enough combinations of keys. And that's about securing your cryptographic algorithms. Now let's say you have got your cryptographic algorithms well done and well designed. Even then, you still have other concerns, because the hackers might be trying to get around these protocols through other means, such as social engineering. With social engineering, we're talking about how organizations are made of people, and these people might not really be very security savvy. So you might find hackers being able to trick someone into revealing information about the system, revealing things like their passwords, and whatever other human mistakes that people can make. So that's where the social engineering comes into play and makes it hard. You have to educate your users. Besides that, poor policies can also cause problems. Example is that there are certain best practices like periodically changing passwords, but if these policies are not in place and people don't actually do that, you might end up with a situation where the system is not as secure as you think, because attackers can spend a lot of time. They have a lot of time. Passwords are not changing. They can gather data at their leisure and eventually might be able to compromise the security of the system. One final challenge here is regulatory constraints. Export controls, for example, in the US, can mean that security algorithms are put in place that are weaker than they might otherwise be, so that the Department of Commerce will not disallow a certain system from being exported out of the US. In fact, that's one of the reasons why WEP for Wi-Fi at first was so weak, because at that time there were concerns that making it too strong might cause problems getting Wi-Fi technology out of the US. Then we get to the wireless specific challenges, and I already mentioned about the broadcast nature of the wireless medium being one of the problems. Because of this, WEP was introduced in Wi-Fi. There was the fact that wired communications was going in wires and the signals were constrained within cables, whereas in Wi-Fi it was inherently being broadcast. So wired equivalent privacy was meant to be something not super secure, but to make the privacy in Wi-Fi somewhat equivalent to signals in wires in a wired network. And then for mobility, you have additional challenges. Devices are changing their network attachment points as they're moving around, and it's not easy for the system to know that the device is actually who it claims to be as it moves from one point to another point. This means that authentication is harder and needs to be done more frequently. And now, last but not least, wireless devices also have constraints. They impose constraints on what we can do from a security point of view. Because of hardware limitations, for example, the algorithms that can actually be used might be limited. It might not be able to use the most strong algorithms. And similarly, battery or power concerns also can limit what can be done. And this is not just theoretical. WPA uses certain cleverly designed protocols that can work even on hardware that is somewhat limited.